All right, guys, so this is the intro to our brand new chapter. We're going to be talking about quadratic functions. So in our brand new table of contents here, we are going to be on, holy crap, I do not know the page off the top of my head. 1 second, please. So sorry, guys. 28. So this is going to be page 28, and we are going to be talking about just some intro stuff. And then regression, which we talked about regression before when we were graphing lines. So this is just going to be a similar thing, but with not a line. Okay, so that leads me to our next page here. And so on this page, right across from our table of contents, we should have these two things here. And I'm hoping that I don't need to write on the back of anything, but just in case. So this shape here is our brand new function, and the shape of this graph, well, I guess let me start with the equation that we're going to be dealing with, or the function that we're going to be dealing with, is a quadratic one. So this is a quadratic, and a quadratic equation can be represented in kind of 3 different ways. And we're going to be taking a look at each different way over the next couple of weeks or so. So one way, kind of the most common way, is y equals ax squared plus bx plus c. Another way is where we have y equals a parenthesis x minus h squared plus k. And then kind of the last way is y equals a, parenthesis x minus r, 1, parenthesis x minus r, 2. Now the thing that makes this graph different or unique compared to our line or to our v graph is that we have a squared variable. Now it kind of doesn't look like we do here, but there are 2 x's, and when I do x times x, that is x squared, and these things are being multiplied here. So the squared variable is what's giving this graph its shape. And the shape itself, this cute little N shape, or sometimes U shape, is called a parabola. So parabola is the shape. Quadratic is the function. And then when it comes to our parabola, there are a couple of key features that we really want to pay close attention to because they're sort of unique and like interesting things are happening there. And so you want to pay close attention to them to help us graph efficiently. And so kind of that most important point is this point right here, which like in our V graph is called a vertex. And this vertex happens to be at 4, 2. So vertex is a super important point. Now, a parabola, or a quadratic function, has a unique feature as well, that it's kind of the same on both sides. So there's sort of this mirror or line of reflection that we can draw in right here through the vertex. And that line of reflection, or axis of symmetry, because symmetrical means the same on both sides, and this is sort of a new axis that I draw in, kind of like the y-axis but shifted over. So this axis of symmetry splits my graph in half equally, so we have the same thing on both sides. And because it is a line, and a vertical line at that one, it's an x equal equation, and in this case, it's x equals 4, because that's the x value that it's going through. So our axis of symmetry is another super important thing. It's sort of this line that is cutting my graph in half and can be super helpful because we have the same thing on both sides. Another key point that we often talk about when we're talking about lines is the y-intercept. And this parabola does have one of those. So we have our y-intercept right here, which is at 0, -6. An interesting point that we don't often talk about with a line, but we could, and that parabolas have two of, potentially, are these X-intercepts. So very similar to Y-intercept, we're just intersecting the X-axis instead. So X-intercepts. This one happens to be at 2, 0, and the other one happens to be at 6, 0. So kind of I'm going to get some highlighter stuff in here. We have our X-intercepts. We have our Y-intercept. All really fun things. And then the parabola, again, is the name of the shape. The other thing that we might talk about here is that this is a pointing down parabola because, I mean, sometimes it's pointing down, but sometimes it's pointing up. So this pointing down parabola is said to have a maximum because this is sort of the highest. So at the vertex, we have this maximum at 2 because that is as high as it goes. So all of those features are really going to come into play when we talk specifically how to graph in each of these different forms here, which we're going to spend some time on later. What we really want to look at today, like I said earlier, is quadratic regression. So if you remember, regression is just finding a line, or in this case, a curve of best fit. So if I have some random data that seems to be following a parabola shape or a parabolic shape, then instead of using a line to approximate my data, I might use a parabola instead. So if we are using a TI graphing calculator, then this box right here can be very helpful in how to find your quadratic regression formula. However, if you don't have one of those, that's okay. Desmos is super helpful too. Now here we don't actually need to do it because I did it all for you already. So I kind of just want to show you what happens. So if I have 3 points and I put them into a table, and so here we have our X values at -1, 0, and 3. And here we have our Y values at 2, -2, and -2. If we follow these steps here, or if I show you how in Desmos in just a second, your calculator or Desmos will sort of spit out the answer for you. So this right here is telling me exactly what I need to know to write my equation in this form right here. So we have our quadratic equation, and they're telling me what A, B, and C are. And so I would just write my equation, y equals 1x squared minus 3x minus 2. So I just put A in for A, B in for B, and C in for C. Now this one is not done, so here is how I can show you to do that. So I don't have a TI calculator. I don't know what happened to mine. It's real sad. I think somebody took it. But I'm going to post a link for you guys in Google Classroom that has this quadratic regression in Desmos. So we're going to clear out our table. I'm just deleting each cell. And then in my X values here, I have a 0, a 1, and a 2. And then we want to put their corresponding Y values. So with the 0, I had a 3. With the 1, I had a 5. And with the 2, I had a 3. And so that's kind of what this down here is. This is where we would set up our table. So 0, 1, 2. And then with the 0, we had a 3, and then a 5, and then a 3. And so if I hit enter my calculator, it would spit out the answers for me. But instead, Desmos down here is going to spit out my answers for me. So we have our standard form at the top there. They're giving us the r squared value, which is like the r value, but slightly better. And because it's 1, that means this is a really good fit. And so then it's telling me that A is -2, B is 4, and C is 3. And so I would just write my equation, y equals -2x squared plus 4x plus 3. So we're not really doing anything. The calculator is doing it all for us. We just need to write it in correctly. Okay, so we might need to come back to that quadratic regression. Oh yeah, maybe we do. Oh no, it told me here. Okay, so let me make this big again so that you can see what the heck I'm doing. So a huge Tiffany lamp hangs from the top of an elegant stairwell in an old opera house downtown. The base of the shade is 5 feet in diameter. I can kind of see that. The top is about 3.25 inches above the vertex of the parabola shown in the graph. What is the height of the Tiffany lamp? So, because the top is about 3.25 inches above the vertex, and kind of, we're going to go with this one as our vertex here. It's sort of not, but we're approximating for now. We're going to talk more about how we would get this actual vertex later. I would take that height, so the 3.8, and add it with the 3.25 to get the total height of the Tiffany lamp. So we're at 7.05. Now also over here, we can write our equation. So they just went through and did all that fun stuff for us. So we have y equals negative 0.63 repeating x squared plus 3.16 repeating x plus 0. So I kind of don't need that. And I'm curious, if I go in to a new Desmos and I just hit graphing calculator, if I type that in, so like y equals negative 0.63, I can't get the repeating symbol in there, but this will be approximate. That's okay. And then the squared plus 3.16 repeating x. And then if I go to the top there, we get 3.9. What the heck? Oh, but then I have to add on the extra, so that's at 3.8, but 3.9 really. So that's pretty close. If I add on that 3.25 to that, we would get the similar number that we had here. So yeah, we're going to go with it. Okay, last but not least, this one's kind of a better one anyways. Use quadratic regression to find the best fitting quadratic model and make some predictions. So youth football, the following table shows the number of participants Y in the local football program from 2000 to 2005. Assume that T is the number of years since 2000. So we kind of have this lovely table here, and they already set it up over in here for you. And my calculator already magically spit out the answer. But again, we could use Desmos and type in this table. And so when I write my equation, I'm going to have y equals 2x squared minus 0.4x plus 25. And if these are years since 2000, so like this is 2000, this is 01, 02, 03, 04, 05, and we want to predict for 08, I got to go 3 more years, which means my x value that I want to plug in is actually 8. And so then we'll plug that in to figure out what the y value is. Oh my gosh, that decimal's freaking me out already. Okay, so we're going to follow a really good order of operations here. So I do 8 squared, which is 64, times 2, so 128. This 0.4 times 8 is going to be 3.2, because we're really like 32, and then move the decimal once. So minus 3.2, right? That's how that works, I think. And then plus 25. And so if we combine these up now, if I take 3.2 away from 128, we're going to be at 124.8 plus 25, so 149.8-ish. I feel like the 0.8-ish doesn't make super sense, but the 149, I mean, that could be legit 3 years later. Like, this is going up. So yeah, that could be legit. And there we go. I think that's it. So guys, on your homework assignment tonight, you don't really have to do much math unless you're plugging something in like this. You're really going to be using Desmos for the most part. So you're going to want to be using this quadratic regression that I posted in Google Classroom to kind of find all your answers if they aren't already listed on there for you. So good luck, and I'll see you on the next one.